right, we are on Unit 1, Skill 5 in Geometry, Angle Bisector lesson. So the essential question is, how is the construction of an angle bisector related to that of a perpendicular bisector that you did previously in this unit? And how do we construct an angle bisector? So now we're constructing one. So the first example is, I want you to know what you know about perpendicular bisectors to try and bisect the below angle ABC. So I'm going to go ahead and annotate really quick. If you're bisecting an angle, that means you're taking the angle and you're creating two congruent angles from that one original angle. So go ahead, take a minute, try something creative and try to bisect angle ABC and pause the video. Okay, so now that you've tried something up here, and again, you're trying to create a line that perfectly bisects the angle in half, basically. So we're going to go down here and we're going to do the together problem and see if how correct you are. So when I look down here, we're going to take angle ABC and we're going to bisect it. So we're going to cut it in half. So our very first step is that we're going to take our compass center and place it on the vertex angle B. Because when I look at this angle, I can call it angle ABC. So I can call it angle ABC, or I can call it angle CBA, as long as that vertex is in the center, that turning point, okay? So I'm going to place my center of the compass on vertex angle B. The next step is that we're going to adjust our compass radius so that when we swing our first arc, we want it to intersect the top line and the bottom line. And what we want to make sure we do is that we choose either the bottom or the top radius hole. And we have to stay consistent throughout the whole construction or else it won't work out. So I'm going to choose the bottom radius hole and I'm going to go ahead and tighten the knob so that when I swing it, it's going to hit the top and the bottom. So with our center on B and our compass ready to go, I'm going to go ahead and swing an arc so that it hits the top and it hits the bottom line. Okay, so now I'm going to remove my compass, and what I want you to do next is place a point of intersection where the arc hits the top and the bottom line of the angle. And then my next step, so what we've done there is by creating this arc and hitting top and bottom, we've created two segments from B to the point on the top and from B to the point on the bottom. These two segments are equidistant, or the same distance from our vertex B, which now ensures that when I do my next two arcs, that these arcs are going to completely directly cut angle ABC in half perfectly. So I'm going to put my compass center on the top intersection point of the top of the angle, and I'm going to swing a baby arc in the middle of this open space of the angle. So I'm going to go ahead and create a little baby arc in there. Okay, so it should look just like that. Then put your compass on the bottom intersection point and swing an arc so that it intersects the other baby arc. Okay, so now you should have two baby arcs that intersect, and again making sure you're using the same radius, the bottom one or the top one, whichever one you chose. And the intersection point, I want you to put a dot there, a point, and then connect. So now our line we're going to draw in here is our actual angle bisector. Okay, so I'm going to go ahead and connect, use the ruler side of our compass, and connect B through that intersection point. I'm going to put an arrow and I'm going to call that intersection point D. Okay, so now I'm going to just make a little note down here that BD is the angle bisector of angle ABC. Okay, so off to the side here, we're just going to do some reflections. So how many total arcs must be drawn in order to construct an angle bisector? Well, we needed that first initial one to create our 2 points that are equidistant from point B, our vertex, and then we needed the two baby arcs to come off of those 2 points of intersection. So we need a total of 3 arcs. Okay, so if you see a construction with only 2 arcs, so I'm going to use this space up here for example. Sometimes you might see a construction where there's an arc here and an arc there, and then a line drawn through that. I know it's a bad sketch, but this is not a complete example because it's missing that initial first arc that we swung, because there's no guarantee that these arcs are in the center of the angle. Okay, so back over here off to the side, name the two congruent angles. So by doing this, if I had the whole angle ABC, so let's say that the whole angle, let's say ABC was originally 60 degrees to begin with, then when we bisected it in half with this line BD, we're creating this top angle, ABD, is going to be 30 degrees because half of 60 is 30, and then the bottom angle is also 30 degrees. Okay, so the two congruent angles that are in our picture now are angle A, we're going to start with just, you know, the end point of this angle, so ABD, so angle ABD, that first green one that I drew in, is congruent to angle DBC, or you can call it CBD, whatever way you want to do your lettering, again making sure B is in the middle, so DBC. Okay, so those are your two congruent angles being cut in half that were cut in half from the original bigger one. So these numbers are just, I just threw them in there, but just so you can visually see that if it was 60, we drew in a angle bisector that cuts it into 30-30. Fill in the blank. So some angle is equal to half of a bigger angle. So if we look at, even with these numbers drawn in, might be helpful too. So angle ABD, the smaller the 30-degree angle, is equal to half of the bigger angle ABC. So that's one way. So it's equal to half of angle ABC, which is 60. So again, these are just arbitrary numbers I'm throwing in. And another relationship that we can draw is the other smaller angle, so angle CBD, that bottom green angle, is equal to, which was also 30 degrees, half of the bigger angle ABC. Okay, so sometimes this shows up in multiple choice where you have to analyze the relationship between the angles. And I think this is a good strategy to throw in some numbers so you can kind of see what happened to the angles and which ones are in a ratio or cut in half. Okay, so we're going to go ahead and flip on over to the next side. And we're going to go ahead and summarize the steps for constructing an angle bisector. Okay, so when I look at the one I just did over here, our first step is to place center of compass on vertex of the angle. Okay. Step 2 is we're going to now swing an arc that intersects the top and bottom of the angle. Step 3, from those intersection points, from the two intersection points, construct two baby arcs, parentheses, one from top point, one from top and bottom point, so that they intersect. In the middle of the angle. Okay, and then step 4 is connect the vertex to the intersection of the baby arcs. Okay, and then this last step is creating that angle bisector line. Okay, so our example number 2 is to bisect angle PSR in the quadrilateral below. Now, if we're bisecting angle PSR, I want you to take a second and highlight that angle so that we know which angle, because if you look, this is a quadrilateral. It's got 4 sides and it's got 4 angles. How do we know which one we're going to bisect? I always look at the center letter, so the PSR, S is in the middle. So I'm going to go ahead and highlight starting at P, going to S, go to R. So start at P, go to S, and then go to R. Okay, so I'm just going to maybe write that off to the side. We're going to go we're going to go from P to S to R to find our angle. And right here, the one in the middle, that S is going to be the vertex angle. Okay, so PSR, here we go. I'm actually going to, for this one, it might be easier for all of us to go ahead and turn our paper upside down, because what we want to do, actually we don't have to do that for this one. We can do it facing right side up. So our steps we're going to do are exactly the same as we did on the front, but our angle is just going to be opened up the other way. So I'm going to go ahead and have you place your compass center on the vertex angle S, and then adjust your compass so that the radius, when you swing it, it's going to hit both PS and SR. So you want it to hit both of these pink lines when you swing your first arc. Okay, so I'm going to go ahead and do that. And we're going to go up, and we're going to go down. Okay, so our first arc, I'm going to put those points there and there, where it hits the 2 sides of the angle. And then we're going to go ahead and put our compass, again using the same radius hole, and place our compass on the top intersection point. Sorry, we can call this the left and the right. And swing our baby arc out in the open here. Okay. And then we want to place it on the other intersection point and swing our baby arc here. So if you do your 2 baby arcs and they don't intersect, that's okay. Just go back to your original starting point and just make it a little bit of a bigger arc so that they do intersect. So you definitely want these arcs to intersect, and then place a dot where the baby arcs intersect. And now our last step is to connect from our vertex through an intersection point of our baby arcs. And now we've created, we can call this a PSRQ, let's call this point T. So we can call this line ST that we just drew in. So ST is the angle bisector of angle PSR. Okay, last one. Let's take a look at this pentagon. It's got 5 sides, so a pentagon has got 5 sides and 5 angles. Okay, so what we're going to do is we again want to identify which angle we're bisecting. So if we're looking at bisecting angle CDE, we want to go from C to D to E with our highlighting, making sure that D is the vertex. So I'm going to take my highlighter and I'm going to go from C to D to E. So there's our angle that we want to bisect. There's a big obtuse angle. Okay, now this is, these lines are a little bit shorter, so we want to make sure that we place our compass on, again, so the compass start here, compass center. Okay, and we're going to place it on D. And now this time it's a very wide angle and the lines aren't very long, so when you swing your first arc, you're going to have to adjust it so that it's brought in a lot, your compass. So you want to make sure that it hits ED and EC before you tighten your compass. Okay, so check that first. And now let's go ahead and make our first arc. Okay, there we go. So our first arc intersected at ED and DC. And now we're going to put our compass on the intersection point of ED using the same compass hole. I'm going to make an arc there and putting it on the bottom one as well. Swing our other baby arc. And then where they intersect, it's okay that it intersects with our original arc. This is just a very small space to work with. Everything's very compact there. And now we're going to connect to make our angle bisector D through our intersection of our baby arcs. And let's call that point, let's see, F. Okay, and now DF, this line, is the angle bisector of angle CDE. We can also, if we wanted to make another like conclusion over here, we could also say that angle ED, so our two congruent angles that have been created are angle EDF, right? Also highlight there. I can say that EDF, so this arc right here, is the same as FDC because the bigger obtuse angle is now cut into two congruent ones. So I can say angle EDF, that one pink, the left pink angle is congruent to FDC, angle FDC. Okay? All right, so hopefully angle bisectors make more sense to you now, and go ahead and try some practice.